So we're now actually up to 50 million, I think. But yeah, our company is MeetKai. We are pretty low-key in terms of what we've done in the past, just because we've been primarily in this very B2B space. But these days, in the past year or so, since late last year, we kind of got pretty interested in the Metaverse world. And big reason for that is that we sort of observed the world of the Metaverse and saw a number of huge issues that AI could address. And for us, that's sort of the goal of this talk, and small groups, so I can leave a lot of time for questions and maybe go higher or lower level as needed. But primarily, the objective is to talk about why I think AI is kind of the useful thing to do for the Metaverse, and more than just kind of a high level of hand-wavy, but sort of really practical ways that we're leveraging AI right now. And we're working with a few pretty large companies and brands deploying this in the field. So yeah, and for us, we kind of got into the XR metaverse-y space when we noticed kind of a really bad trend in the industry. And that's sort of how we started as a company in 2018, when we saw that voice assistants were being very poorly received, but that there should have been more interest. And if we look at where we are right now in the field, whether you look at VR or metaverse, we're on this decline. And I think that's not a good place to be. I think the large reason for this is largely based around the sentiment. I mean, the talk just now said oh, the M word. Because I think when you say metaverse, people get turned off now. And likewise, if you look at public sentiment in social media and things like that, this was a post on Reddit that I found from 2 months ago, where it was yes, this isn't meta, but still the sentiment around the metaverse right now is so unbelievably negative that as an industry, we really have to figure out a way to get around that. And doing that starts with figuring out why does everyone in the industry think so poorly of the metaverse. And my hypothesis in theory is it's all about content, and there's no value. If you look back at early PCs and things like that, there's so much stuff you could do with them. You go back and look at mobile phones. In addition to making phone calls, once they had an app store, so much you could do. You look at anything talking about metaverse or XR right now, we talk about different things in industrial training, or maybe little experience here, little experience there, but it's not substantial. It's all pretty lightweight. And the reason for that is just that the content is, one, there's not enough of it. Two, the content that exists, I think we can all agree, is pretty weak. If you compare content in XR and demos in XR, and I mean, I'll speak for myself, we've done demos in content in XR, it is weak compared to what can be done in an app. And people's sentiment, I think, reflects that. And then, most importantly, to get that weak content right now, it costs too much. You're spending similar amounts of money to develop a mobile game as if you want to create an XR game, or perhaps even more on the XR game. And the market size for XR is so much smaller, so it's this very bad cycle. And content really is that issue. And we saw this, observed this, and thought, we're really good at AI. We've built AI solutions that are pretty complicated in the past. Is it possible to leverage some of that tech and sort of develop new research as well that can kind of fix this content problem? And that's kind of the goal of what I'm going to talk about now, is how, one, anyone can use AI to make better content for the metaverse, and two, how we're actually doing it right now in a very kind of applied way. And most importantly, and I think this is kind of off the beaten path from what people usually talk about with AI, most people like to talk about, the more sexier parts of AI that are immediately visible and cool commercials and things like that. But the graphics of how you put together AI, and I'm not talking about digital humans or body scanning and things like that, much more so just how do you make the content look better and be cheaper to make. So it's really based on generative art, scanning, and most interesting and novel that we do is asset optimization. If you look at generative art, stable diffusion is the new hot thing that everyone likes to talk about, of going from text to X of images. But there's been a lot of talk in academics and some of these FANG research companies of okay, can we let someone say, okay, I want a cat with 3 spots that's red chasing a dog and getting a mesh for that. And we sort of started a research project of our own to do that and found out it doesn't work. Problem is that the art that you generate automatically isn't really good. And by that, I mean if you actually look at it from the perspective of a game and try to put together an entire game with all this generated art, it's just, there's no cohesion, there's no style, and most people that look at it and would play it would say, oh, this is a crappy game. And you can already, right now, go on the Unity asset store or whatever, buy a bunch of assets and put it into a game, and it's effectively the same thing as generating them from scratch. There's no real difference. What is interesting, though, that we found is texture generation. So one of the things that we have put into production and are using quite successfully is stuff around generating a texture based upon textual descriptions. So this is pretty useful in that a lot of times in scenes that we've put together, especially like things with walls, things with floors, things with ceilings, you might want to have variations in terms of like red bricks, gray bricks, cobblestone. You know, if you look at the streets out here in Lisbon, floor right there is textured in a very particular way. It would take work to actually do that manually, but it gets you pretty far to just use a text-based generation of those types of textures. So this is something that people can do right now. You know, there's a Blender plugin that's open source and getting pretty good. You know, we've used it pretty successfully. I think other people could too, where you can just take a mesh, an object in Blender, put in a description of what you want for the texture, hit generate, and you get a seamless texture that works. Second thing that we've sort of seen success in and a lot of trending on, let's see if we go to the next slide, is scanning. This is probably the hottest topic right now, since if you look at most of the experiences that you see out there in XR, the graphics look like low poly. And you know, you look at a lot of these scenes, and there's just a bunch of low poly objects collected with each other. I mean, that's how Horizon World looks, just a bunch of low poly objects. And there's sort of two reasons for that. One is that it's cheaper to create low poly content, and two is that it's easier to render low poly content, just by the nature of it being simpler content. However, there's been a lot of push, and I mean in the Connect demo from, I guess it's a few weeks ago now, there was kind of two approaches that were pitched as like part of like, okay, these are two different ways of doing it. And most of them are more broadly defined by inverse rendering, which is that you take a bunch of pictures of a model, and then instead of trying to stitch those together into a mesh, you use a deep learning technique to try to recreate a scene based on the light paths. This sounds really cool, and it does work in that, you know, you can give it a photo, like NVIDIA has a tool, you can download it for a PC if you have an NVIDIA GPU, you can run this, get that cool Lego, I don't know what it is, a dump truck of some sort, but it's just for a demo. Like, it's very, very far out from actually using it in any type of XR or metaverse space, which is unfortunate, because it would be a really nice thing if we could just scan the world around us and all of a sudden immediately have a metaverse experience that looks like really hyper-real and everything like that. And most importantly, I would probably say, is the NVIDIA tax. Like, if you're actually trying to build a business around these things and you have to pay for NVIDIA enterprise GPUs, it just doesn't work out. And what we found instead, though, is that what is interesting and what does have a lot of potential is in using drone images to try to create much larger scale spaces. And this is something that we've been exploring in a more industrial setting, where you might be able to have drones that fly around some region of like oil fields or pipelines and things like that, and you'd want to have a 3D reconstruction of it. And with that reconstruction, you can end up like exploring it from different angles, and it's a pretty cool feature, because then it's like you get to take the drone capture footage once, and then anyone else can like pretend to be a drone as they explore the world. There's a lot of stuff going on here. I think this would go super, super deep if I tried to like give an entire talk on it, but the idea that's really powerful here is that previously when people tried to do these types of large-scale scenes, it would take a lot of work at like pre-processing and like splitting up the world manually. And you'd have to have like the people scanning photos to be like, okay, this is area 1, this is area 2, this is area 3, this is area 4, area 5, area 6. Versus with these new approaches, you can just take, someone could walk around this entire conference hall, take just a ton of photos, and the models would learn to partition the space in the most intelligent way, such that maybe it makes sense for this room to be one space, maybe it makes sense for it to be 2, 4, 8, it depends. But models are much better at learning how to do that than people. Unfortunately, though, most of the stuff that we've seen in terms of like object scanning is still kind of weak, in that it's going to take some time before you're able to just like scan a space and have it be interactive. And unfortunately, most of the tech that you see out there of like Matterport and things like that, they don't really create immersive spaces. You create a space with a 360 view, but you can't like move objects. It's like a just read-only as opposed to read-write. And most of the things that we've done and talked about with different companies are all really trying to do like read-write sort of concepts of like they want to have a space brought in and then be able to move things around or have people come in and out and things like that. Coolest thing that we do now, though, and probably the MVP of what makes a lot of the scenes that we put together look really, really good is related to asset optimization. And this is something that almost nobody talks about because it's such a pain. And it's unfortunately where most of the money, I would say, in a lot of these projects go. It's like, okay, our artists put together this really great, beautiful scene, and then the engineers try to get it to run and it doesn't run. It hits 4 frames per second, or takes like 15 minutes to load, or it's 2 gigs, and they have 8K textures everywhere, and it just doesn't work. So this usually acts as like the real problem in getting scenes to look good. And what we figured out, and I don't know if other companies are doing this and not talking about it, there haven't really been many papers published about this, but I want to encourage others to use it, just because I think it's such a nifty technique, which is that it is the perfect application of AI towards XR. And it's probably the most important application broadly to 3D in general. And at least from what we've seen, it is the trick that gets our scenes to look good. And the intuition behind it is that it is not hard to conceive of a method with which you can take one item and another item and measure how different they look visually. It's a very common problem that people do all the time. Whenever someone does reverse image search, common issue, right? How similarly are these 2 items visually? And you can imagine doing that in 3D is not that hard, because you're just extending that to different angles. How similar does this item look to this item from this angle, et cetera, et cetera. And likewise, it's easy to imagine how you're going to measure performance. Like, very trivial, right? You drop an object in the scene, what's the frame rate, GPU usage, frame time on GPU, frame time on CPU, et cetera. If you have those 2 things, which are trivial for anyone building anything in 3D with sufficient engineering capabilities, then it becomes very, very, very trivial to do this. And what we do is basically we have one model that's doing the perceived visual similarity. So what we do is we start off with an asset from an artist that's a really high-quality mesh and texture. Then we drop that into a scene. And then we incrementally apply optimization to that with reinforcement learning. And then every stage of applying that optimization, we render it from like 80 different angles, compare it to the other model, the original one, from 80 different angles, and see how far they've diverged. Then we have a secondary step of like, when we're doing it from those 80 different angles, we're also measuring the frame rate, the memory usage, everything, and seeing how far that's diverged. And we set targets for like, what is the required FPS relative to the visual loss we're willing to accept. And by doing that, we're able to basically solve a problem where otherwise you would have to have artists spend hours, weeks, days, months, whatever, just saying, okay, this still looks good, let me see if it runs well. And going through this entire pipeline of having it go to the engineers rebuild the scene, see if it still works. And right now we're applying this where essentially for like a retail store we built, we run this across all of the products themselves, so they all get optimized, and then we place them into the scene and repeat that process. Because what you find is that, like, let's say you spent all this time optimizing a diamond ring, right? And then you place it into a store, and it turns out you can almost never see the back of the diamond because it's VR, right? You can only see it from so many angles. Then the model can learn to optimize away the back of the diamond because there's no visual perceived loss, because every time you render the back, the difference is 0, because you can't see it neither the before or the after. So this has been very successful. Most likely, we're going to probably productize this as a company at some point, but I think it's definitely something that a lot more companies could benefit from doing. And the reason why I'm happy to talk about it is primarily that I think if you look at like what people are doing with AI right now and talking about art and assets in general, I think it's really kind of silly, because the topic is usually, okay, AI is going to replace artists. All of a sudden, no one's going to have artists on their payroll anymore. It's just going to be a bunch of people using these models and putting in different text to generate different meshes and whatever. And I don't think that's going to happen. What I do think that can happen, though, is that you can take each artist and drastically increase their productivity just by giving them these types of tools. First ones being tools that help them with texture generation, which typically right now requires them using Substance, and generating normal maps takes a lot of time. And the second thing is by using better ways of doing object scanning and scene scanning and not wasting too much time on techniques that won't have any actual implementation. And last one, and most importantly, is this asset optimization step, which people spend a lot of money right now on asset optimization tools. I mean, there's like proprietary tools that exist that just do asset optimization, and then those tools require you to have experienced people operate them and then manually test the performance when they're running the optimization. And it's much better to have just a whole bag of tools that just do asset optimization in random ways and have a model figure out the optimal pathway to optimize that asset. So, other thing we're doing with AI that's pretty fun is voice. A lot of companies talk about like voice assistants, voice UX, things like that. I think humble brag, but we're probably the largest company that no one's heard of that's done like a voice assistant on a very large scale in a very large number of languages and regions. I think our voice assistant has a little bit over 30 million users now and is in like 7 different languages and I think about a dozen countries. So we've done a very widely deployed voice assistant. And what we're doing these days is that, if we talk about digital human, like this is an experience that we have going right now that's in testing for a jewelry store by a company who can't be named. But they do very overpriced high-end jewelry. Hopefully I'm not being recorded. And essentially the key with this is that the interesting part of the voice interaction is not necessarily just like, okay, how are you? I'm okay. What's your name? It's rather having them be able to interact with the store at large. And this is, I think, where we talk about the metaverse and things get more interesting to me. And this was actually our original idea for getting the metaverse space is, hey, we'll just build these NPCs, let other people build the metaverse. But we found the content that was going to host these NPCs was going to be so bad that no one would care about NPCs. So that's what motivated us to spend all this time building metaverse tech, et cetera, et cetera. But voice, I think, really is going to be the only useful way of interacting with XR content, because if you have ever built an XR experience and tried to demo it to people, not at a VR convention, like at a regular convention, they don't even know how to hold the controllers, right? They grab them the wrong way. They're like, why do I have to hold 2? They put 1 down. They only hold 1. And it just kind of shows that okay, we're not going to be able to rely on people to understand 6-DoF controllers. And we're not going to be able to rely on people to understand how to do weird hand gestures for UI. Voice is going to be how people interact with scenes. And that's really where we're researching and focusing on. So the other thing that's fun with AI here is dynamic spaces, which is that there's no reason why a space has to be fixed. Game dev for so long has always been, okay, we're going to make this scene and then ship this scene and people will be able to play that map, right? There's no reason to do that. And there are open world games and things like that where they've had, okay, this world is dynamic and adjusts based on your choices and things like that. But for whatever reason, when we look at this metaverse space, no one is really applying a similar concept. They're all building the same store for everyone. And that's silly. It's much, much more interesting if we leverage the fact that these 3D spaces can be dynamic to make them dynamic. That's the entire reason why we are spending all these calories to make spaces that are 3D instead of just photo recreations. Because you want to be able to have the idea of a store where depending upon who's in it, it changes. If you have a Nike store in real life, there's a women's section on the first floor, and then maybe there's a men's section on the 3rd floor. Or any department store, the men's section is always far away. If you only have men in a store, though, there's no reason to have your store set up like that. Likewise, if there's only women in the store, there's no reason to even waste time with having the men's section. So by allowing these spaces to be dynamic and personalized by the user, it becomes much more interesting. And I think this also is one of those things that makes the metaverse. So that's sort of the high level. I'm happy to dive into the lower level things of how do you actually implement some of these things on a much more ML level, or I'm happy to answer questions, I guess, really briefly on language models and things like that. Key here for how you make your models actually work is that you really have to encode the scene. Most of these models that people talk about for digital humans do not take into account the scene in which the NPC will exist. They are purely a conversational model where you add in an avatar on top. But the moment you put them into a scene, they start struggling because they have no idea of what the scene around them is. And when you start having this idea of dynamic scenes with dynamic content that adjusts on who's there, then it becomes extremely important to have ways of the NPC understanding how that scene is encoded. So effectively, that's how you really have to build these models, and that's sort of what we do. Basically, the idea of how you can implement this is, if you're sufficiently motivated, is that you can mask out certain regions of the scene and then train a model to predict what should be there. That's how all language models work. I mean, most of these language models people talk about are based around predicting the next word or predicting the missing word. You can extend that to a 3D space by deleting an object and trying to train a model to predict what object used to be there. That type of technique works really, really well, and surprisingly, no one talks about it. Partially secret sauce, partially just no one is really working in this space. Other thing is that these models are expensive. The thing that most people don't talk about with digital humans, et cetera, is that they are really expensive. If you want to train and host a custom model, each custom NPC, if you're doing it the wrong way, takes about 8 NVIDIA GPUs. And cheapest NVIDIA GPUs in a data center are running you about $1 an hour. So that's $8 an hour for any single NPC model, which scales terribly. Because if you imagine having 100 users interacting with the same NPC at a time, you're not going to be able to serve that on one model. You're going to have multiple servers servicing those users. So all of a sudden, you're looking at the cost of hosting this NPC to be more expensive than just having a person pretend to be the NPC. And no one likes to talk about that, but that's ironically cheaper. So if you actually want to do these things, you have to go from the beginning in terms of like, okay, this is going to have to cost less. How are we going to do that? Other thing people don't talk about is toxicity. No one likes to talk about when the models are racist. They all like to pretend these models are like perfect, but they're not. So like from the beginning, you have to start understanding of what happens when someone says something toxic to the NPC. How do you respond? And how do you make sure the NPC doesn't say anything toxic? It's like, do you hate Americans? Agree or agree? If you said that to an NPC, like, if it's stupid, it might just say agree. It's a challenge. So you have to really, from the beginning, understand, like, okay, toxicity is going to be really, really scary. Other than that, I know I'm short on time, and I'll jump to questions, but shameless promotion. We have a number of open source projects that we either sponsor, develop, or otherwise involved in. Naya and Superconductor are the two ones that we build. One of them is a net stack. The other one is a rendering engine. Very experimental on both, but we feel are better than most open source tools out there. There are closed source solutions like Wonderland that's better than our Superconductor, but if you want to do an open source solution, give ours a shot and mess around with it. We also contribute and sponsor Wolvik and Bevy, which is another game engine. Cool. All right, questions? Short on time.
It was worth coming to Lisbon. Thank you for that.
Of course.
I was quite fascinated with the dynamic changing
Yeah.
space. So currently, I'm in the business of taking brands into Metaverse, and I give them the best advice I can from my experience. This is something new that I never thought of. So if I said to them, why don't we do this, then first customer that walks in there, how is the AI going to recognize what that customer is?
Sure. So personalization, I mean, basically what you're doing for like a store is you have to encode like where things are allowed to legally be placed according to some rules. Because like you don't want to have a mannequin now have like 10 hats because someone who likes hats walked in. So you have to.
Sorry, let's have this interactively.
Yeah.
So if a woman walked in, could my Metaverse shop show more female
Yeah.
accessories than male shoes?
Correct. The first person that enters defines the original characteristic of the store. And then typically what we found is that the first person is very similar to the second, third, and fourth as it goes on and becomes increasingly confident. Like if you see woman, 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 men, then it would make sense that the man is the top floor. Otherwise, if you see woman, man, then maybe it goes women's, men's, and then bias is more towards the other as more people come in and exit.
And also I'm thinking of using, I don't know if you heard the company Promethean AI, it's a Ukrainian company where they allow us to, anyway, I haven't tested them, but I'm hoping to go and meet them and speak to them. They're an AI metaverse company, and basically the demo says that I can, through voice, I can say, I want 10 chairs, and then 10 chairs up here, I want this,
So
that.
you can do that. We tried that. That was one of our early experiments. The problem was that it wasn't like what you got out of it didn't look good enough because it was mostly like, okay, now it's 10 low poly chairs arranged in a single row.
Well, I mean, they went beyond that. They obviously
Oh, of course.
started, and they allow you to size it, change it.
Yeah, it's
X, Y, Z. You're saying that doesn't work. There's a better way of.
I'm
Basically, I'm trying to get big clients to build Metaverse, and I'm saying that everything they see out there is crap.
yes.
That they shouldn't do anything like that, and they shouldn't have like silly staircases and
Yeah.
difficult doors to go through. There must be a more sensible architecture
Yeah, I mean, happy, like, I think I'm out of time, so why don't we talk after? But yes, yes.
I want to know is that what you're talking, is it like development stage, prototype?
We have deployed solutions, and we've built solutions using these types of things. Mainly my goal is to motivate others to use AI in sort of these types of interesting ways, because for us, we're building on the web, and we're big believers in WebXR, and our goal is that the more people that make good WebXR content, the more the web will be taken seriously. And right now, I think that's the problem, is that you see people building things in Unreal and using pixel streaming and stuff like that, and like, oh, that's what things should look like. And then they see what things look like with WebXR, and like, oh, wait, that doesn't look good. So our goal, and my goal, is just make better people make better content in the browser, and that will kind of, rising waves, help all boats. So yes, I think there are many ways you can apply this. It works. I would say some things work less well than others. I would definitely say assets, though, and saving money on artists has been the biggest thing we found.
All right.
Cool.
So we run out of time, but if you still have questions for James, I'm sure you can talk
I'll be outside.
later.
Okay, thank you.
Thank you, James.